Hey everyone, I hope you guys are having a fantastic day today. So what we kind of did today was I had the AP Physics 2 and AP Physics C teacher come in to talk to the juniors about their upcoming year and see what type of options they have for classes. So that took up a decent amount of time. I think my two virtual students, you're both seniors, so I won't go into full detail about that. I did mention that our AP exam is dated for May 24th. Okay, it's on May 24th. It's the afternoon session. Okay, so just thought I'd let you know. So you guys, that's exactly 3 months ahead. Okay, so we have plenty of time to get through the last chapter and a half and review information throughout the year. Okay, so we went over those two things. I showed a couple videos. What I'm going to do is I'm going to post the links to those videos here. And it talks about elastic collisions. Okay? Basically, elastic collisions, the two objects bounce off of each other. Okay, and I'm going to show an example from our notes. So what I'm going to do here is I'm going to present my screen so you guys can see what I'm showing. Just going to do one example, all right? We'll be good to go. Okay. Here we go. So when we look at elastic, okay, when we look at an elastic equation, let me find one. How about number 26? Okay. When we look at an elastic equation, and you know what? There was some notes on this slide. Sorry about this. There we go. Just some notes I want you to copy down about elastic collisions real quick. And if you want to pause the video, you can do so. Okay. There we go. Okay, so some basic principles about elastic collision. Kinetic energy is conserved. Now that's huge. That's a huge factor to realize. Kinetic energy is conserved. When objects of the same mass hit, they just switch velocities. When a bigger object hits a smaller object, this bigger object will tend to go the same direction, where the smaller object will rebound at even a faster speed. Okay, so let's try out number 26, just to see what type of problem this looks like. Okay. Oh, didn't mean to do that. So 26. Since the two objects are bouncing off of each other, we look at my momentum initial is equal to my momentum final. I'm going to have m1 v1 plus m2 v2. Oh my gosh, m2 should say velocity initial. Velocity initial is equal to my mass 1 velocity final plus mass 2 velocity final. Okay, so let's see, my initial mass is 4, velocity is 2, plus mass of 6. My velocity is moving west for mass object 2, so negative 4. Mass is 4. Final velocity is negative 5.2 plus 6 times VF. So you got to solve for VF in this situation. Okay? You got to solve for VF. I have the answer with that somewhere. Man, I thought I had it. I don't have my calculator on me. So VF should have equaled 0.8. 0.8. Okay. VF should equal 0.8. meters per second. Okay. Now, to solve for the initial and final kinetic energies, okay, so remember my initial and kinetic can be conserved. So initial, so object 1, so mass of object 1, velocity of object 1 initially, mass times velocity, 1/2.
My brother's probably waiting on the key.
Mass velocity squared plus 1/2 mass velocity squared. Okay, let's do our kinetic energy final. So 1/2 mass velocity squared plus 1/2 mass velocity squared. Now, when you look at those, when you calculate the initial and final, what you're going to see is both of those equal 56 joules. Both of those equal 56 joules because our kinetic energy is conserved in an elastic collision. So, all right, so that's how you set up an equation. All right, it's just very similar to the explosions and collisions that we've been dealing with. So we will be doing a virtual lab over this. We'll be checking out some different problems of this. So if you guys have any questions, let me know. Like I said, we'll be doing a virtual lab of this tomorrow to analyze the equation and derive it a little bit. So I hope you guys have a fantastic day, and we will see you tomorrow.